Okay, welcome back. If anybody ever reads this or watches this thing, we've actually got videos with 0 views. That's hard to do. But when you're the poorest watched videos on YouTube, I can find nothing searching YouTube that has less views than us. Or less subscribers. 11 subscribers is not a lot of subscribers. But I think they're loyal because I get about that many views once they've seen them all. What you're looking at here is where the banana trees were growing on the video this is continued from. And we left that void in the gutter. And of course all the water runs in there out across the yard. And now that we have a cistern, you know, we want to try and put water in it. Over here's the bananas. Those are those cooking bananas that you make a banana Q out of. So apparently they're showing us they cut the bananas down, and 10 minutes later they cut the tree down and put the cement in it. We can't actually put water in any of the tanks yet. They're not painted. The thing is it's awful hard to clean algae and stuff off of rough concrete. Now the concrete, you see this is what poured over here on the left. Can you see the pointer? That's a post in the house, a column. Columns now. Post and beam is column and beam. Figure that out. But it's like a parking garage. But that's the finish that comes out of the forms. This is not rendered or anything like that. That's just what the concrete looks like. And the tanks will look like that. You can see them in the videos. This is just smooth. When we want to put render on it, we put on 2-inch 8-gauge welded wire mesh. And that's put on with like 2-inch or 2.5 concrete nails in a 40 millimeter or 4 millimeter hole. You drill a hole, and then you put a flat washer on either side of the mesh, and a 7/16 ordinary, that's not rustable, you know, metal nut, and then you drive the nail in, and about every 18 inches. So mechanically the render is attached to the building. I can't see taking and chipping and damaging the surface of all your concrete, trying to stick a render in it just to make the thing look better than it really is. So we don't knock divots in our concrete anywhere. Not happening. You divot it up. I'll show you where the jackhammer is. You get to take it back down, and we'll pour it again. We don't only take it down. We make them save the rebar tied just where it is. All we got to do is set the forms around it and, you know, start mixing bags of cement. Okay, those are the bananas that came out where they poured that continuation of the gutter. Okay, my wife wanted to see how long they were cutting the tie wires because the ends are pointy, sticking out. And that's because nobody takes their thumb and bends them straight down when they're done tying them. I don't see the tie tool. Well, yeah, this is the end of the tie tool, the part that sticks out this way. The other end, this is ball bearings. The other end's got a hook on it. And we have some other ones that I haven't seen them using yet. They're like the old Scotch Cross drive screwdrivers from years ago. You pushed them in and out, and it spun the bit. They made drills that way too. Anyway, we have some of those that twist these things, and a couple of the guys when you're doing stuff in place, they have a piece they've bent out of a piece of rebar, put a point on it, and bent the end. They're about half as fast as the actual tool because they've done it so much with it. These you go to buy a shop vise. You go to buy a shop vise like this over here in the States. 8-inch vise in the States would probably cost you $200. These vises are made out of plate that they've cut, welded together, and ground all the seams. So it's a steel vise. You'll never see one of them snap in two because it's steel plate. Unfortunately, the lead screw is not much. It's, well, could be better. Tried to close the picture down, but smaller. I think this is him showing he planted a banana there. He planted a banana here. He planted a banana. There's a row he's putting in of ones he's moved. This is standing on the other side looking at the actual bananas. I'm not sure what this thing growing here is, but apparently it's something to do with food because he didn't chop it all to pieces. He'd have leveled it if it was purely weeds. I don't think it's flowers. That's too dense. And I don't think it's a Delpha. I'm not sure what it is. This is going to turn into ornamental grass. I know where that is. That's down behind the house. Do we have anybody else that has something we want to look at? No, we've seen those. It's just showing us a bushing that tore up in the mixer motor. Okay, let's go somewhere else here. This drawing has been renamed. It was called Concrete Ladder because it looked more like a ladder. The idea of these stairs is that we get a lot of rise for a little bit of run, and we leave room for getting your foot on there by slanting the riser. We call it a ladder because you have to face it going up or down. You can't go down facing away from the ladder because you basically, your leg and your heel would come here and the rest of your foot's hanging out. So it actually is a ladder. And the reason for having it that steep is this is going to go down into the cistern and the tilapia tank. And I'm thinking real serious about doing the same kind of thing to replace those construction stairs that fell all to pieces. Bugs just carried them away. You know, it wasn't even rainy season that carried them away. So what I did, they're this steep so that we don't have to have a very big manhole up here to get head height going up and down. The idea was that the amount of hole that we had to have up in the top of the tank, we didn't want an 8-foot wide hole up there. But I got to thinking if the guy's walking down this and leaning forward, he doesn't need much of a hole. So why not just make them, you know, less steep? And actually I can make bigger treads. So the second drawing here was done in about 8 seconds. It's transform, scale, and non-uniform. You hit 3 clicks. And it asks you how much you want to scale the X, the Y, and the Z. And I made it X is 1.25, and Y and Z are both the same 1, you know, that they were. So basically, it came out looking more like stairs. Still way steeper than 45 degrees now. It's got a tread width of just under 11 inches. And rise is 7.5. This fails 4 out of 5 U.S. codes for stairs. It might pass the Navy code, but it will pass the Coast Guard code. And then you have residential, commercial, and a few other things that everybody has different specs for steps. This would drive you crazy. I built a lot of steps. I used the Coast Guard codes so I could show them the book, and I had a copy of that. The deal is when you pour it, the tread plates, they're off. You leave them off on the ground. The sides of the forms are held together with these the risers, slanted back risers. They're screwed into number 1. And I haven't got numbers on those yet, but there'll be numbers. This is a work in progress. I'm just doing it today. Anyway, this gets screwed into that, and that keeps it all right. And you pour the concrete up to it's about a 1/4 inch higher than the tread, or 1/2 inch. You drop the tread on there, and then you slide it back and forth to act like a trowel. That pushes it down towards absolutely flush, and you put a screw in each side, 1 screw each side. And then you pour the next one, because you get a big open hole to dump it in. We learned a lot with our helical stairs, and there's various stages of construction on those other than the forms. I think the forms were down before we ever started doing videos. But the helical stairs were a nightmare. It took 2 guys a week and a half, and one of them decided he'd just do anything else, and he snuck upstairs and learned metalworking. He had to work on the window grills. And the one that stuck it out, he's working with us for life. He got to reward loyalty a little bit. In any event, you have to have a drawing first. At least we do. I don't know about anybody else. Materials are so expensive. And the time on the computer is dirt cheap. I don't get paid. And this is, well, let's look at the parts that are actually finished. There'll be a drawing here first of pretty much an assembly drawing of the pieces of plywood. I don't know if... Okay, this is one piece of plywood. And along the side of it, we have, well, what did I did there? We have dimensions, measuring from the end down, and on the first sheet, there's another dimension. It's not on this one yet. Slight omission. That's how much the you go down to get the second point. And there's a line drawn at 10.0268, one end to the other, and that's the intersection point. That line and this dimension gives you the points to draw this zigzag sawtooth. And this dimension to here and that dimension lets you cut that corner off. Same thing, there's dimensions for these. Always measure from the same side. Don't ever switch up, because the plywood's never the right size here. And the green line's just a line. And the piece that gets cut off the bottom, this piece, it gets flipped over and put here to cut this other corner. These stairs are freestanding. Center of gravity is somewhere right in here. And then the base goes out that far. The base does not go as far as this, because I want to make sure this gets up to, where I want it to land. Now, if I make them the same, there'll be something down here for sure, leaving me about a 3-inch gap to fall in up there. And we don't want the old people falling in a gap. So they'll get a drawing of the pieces of plywood. Here they are turned down so they fit all the same way on a piece of paper. And the same dimensions. It's just broken into sections. So what to cut? You know, cut me one of these and put the notches in it, and cut me with one like this, and take that piece and cut that chunk out of it. And those dimensions are pretty much done, ready to go. I don't even have to check them anymore. I don't think. I think because they're basically the actual scale parts, just separated from the drawing. There's been no alterations in them once they were moved. Oh, this is a sample tread and a sample riser. It's 4 feet wide, and I'll have to lay some plywood across it to get the mixer up and down, because the mixer tires, that would hurt some if you tried to come down something like that. If the tires would fit completely outside to let the axle slide down, it might be all right, but I think we'll probably just lay some plywoods across there. The mixer's not heavy without the cement in it, you know. Don't weigh that much. I mean, we pick it up and carry it around, so. All these pieces will have the dimensions put on them. Like, you can see this doesn't take forever. Where's my... Okay, next thing about designing things for the Philippines, I draw in inches. You have to know if the magnitude of your numbers makes sense. You can do a lot of things that it'll measure it and you have numbers, but you'll have screwed something up and you don't realize it, that the stair tread is only 5 inches wide because it's in centimeters and they look 2.5 times as big. And so you get some surprises if you're not used to, if it's not your native language in CAD. So I draw in inches. And when I get done, I just go back to basically to zoom to the extent of the drawing, and I'll make a copy of this same drawing, and I'll call it concrete ladder metric. And I'll open that drawing up, and I'll put an origin point over here, and I'll scale the entire drawing in 3D by 2.54, and that will get me all my dimensions changed to metric without having to measure anything. And I've not found the computer to ever screw that up. If it's been screwed up, it's me. So this is a little bit of how we start out doing something. Our concrete forms are all designed in this. This is Rhino 3D. You don't have any kind of a yearly charge on it. It's a lifetime license. I bought a commercial license. I don't know if they have non-commercial license, but I know they have commercial because that's what this one is. And I have, for instance, on this drawing, I'm gonna take these pieces. Well, I got numbers goes in these circles. I haven't put it. That's where I was when I stopped. Went for lunch. But I'll put numbers on it, and then they'll have the full scale drawings up here. They'll be printed of the dimensions of those pieces. The numbers here will match the numbers on the parts to cut. So when they stick it together, they kind of have a chance of finding out where it goes. See, like you can count. You need 1, 2, up to like 19 number ones, and need 18 of these number twos. This number 3 is only one of them per side, because most of them are like this number 1. It's longer, but same at the top part, but the bottom's cut off. And then you have the number 6. Number 8 is an addition from the original steeper stairs. I was going to put a rounded corner here. I thought it would aesthetically be nicer. But they're just not that kind of an item. Because everything else is straight lines. So I thought, well, just put a flat slab in there so the corner's not such a load concentration. This goes over top of our gutter. You know, gutter goes over and down and over and up and over to the house. And this top end butts up against the round edge of the roof. And we're going to do these before we put the molded edge on the roof. It's cast in place molding. So it'll start and stop here. Now the reason these stairs, one of the reasons these stairs goes on there is we weren't thinking about having a ground mount solar panel system. But I'm not there to do my wind turbine. And just to shorten the duration of the job, we're going to buy 25 solar panels, put them on the ground, and I have to have a way to get the wire to the electrical room, because this house was originally planned to have grid power, but they won't give us power, so screw them. If I don't have power, I can't get the certificate that goes along with it, and they can't charge me taxes. At least they're going to have a tough time because they won't have a serial number to do it with or an address. All the numbers they need to fill in their piece of paper won't be available. So we'll let them worry with that. I'm not going to worry with it. If I owe taxes, I'll pay them. I mean, they'll know whether I owe them or not. They'll know I owe them. They just won't know how to collect them. In any event, this is going to sit on the gutter, so there'll be an additional chunk that will go up, over, and down, so it's taller than the gutter. Don't know why. I guess in case some kid's floating around in an inner tube in the gutter, he can go underneath the stairs. Just breathing room. Because when you take the forms off, you know, it'll leave that shape in the concrete. Oh, well, where I got off track. I'm as bad as I was when I started doing these. This gives me a place to run a 2-inch pipe from the ground up to this first floor level. And it's going to come out here and run along under the edge of the roof. And actually, I can run it out the side at this level and hide it in the molding that goes on the edge of the roof. You'll have to look at another video. I can't describe the shape of the curb. It's got a lot of rounded and edges and protrusions and stuff. But this floor is 6.5 inches thick at the edge, 8 inches at the center for drainage. So I can hide in that molding. I can hide a couple of 1.5 inch pipes, and one for solar in, and one out to the dirty kitchen, and I can have you know, the wiring's in for the grid electric, all the breakers and the meter base and the panels and breaker stuff inside the house. It's pretty much complete. But I got tired of talking to the people. They just come up with a new piece of paper every time you go there. I don't think they know how to actually do the paperwork. As far as I know, I'm the only foreigner for 3 towns. We're out in the provinces. And so, you know, we have to have the building permit and all the adjacent paperwork and architectural plans signed off by 8 different offices. The stuff has to be blueprint, can't be inkjet printed. It's just a bunch of rules. And so they have to, you know, they tell us the piece of paper they want us to get and fill out and who to see and all that. They're real, just cooperative, friendly people when you're there. They treat you really well. But when you come back, they've had time to look through the filing cabinet. They find 3 more forms that they didn't know about when you were there, and they want them filled out. So we did that for 3 build seasons. And the last year I was there, I never went and saw them. And now I think it would be just as cheap to put in the solar system. And if I can get my turbine finished up, I'm going to put it up on the roof. That's where it goes anyway. That and the solar hot water heater goes on the roof. Not much else up there. Okay. I'm going to get these drawings finished up and put them in a folder. And we don't have to have full-scale prints for this. the print for each of these sections would be about 750 pesos. There'd be 1, 2, 3. To make this background shape would take 2,250 pesos. So basically $50 for those 3 pieces of paper. I'm thinking that Benji and Boyette, I've given them a lot harder things to do off of drawings. They didn't know how to read drawings when they were fishermen, but they know how to read them now. So I'm just going to risk a piece of plywood and let them cut it out. I wish I could see the with the lines they drew on their cell phone, you know, with their cell phone, and like we have pictures and stuff. If I could get them to do it with the yellow paint marker, I could see if it looked like it was right. But the line would be too wide to cut at that point. I mean, you can't cut a line that's a 1/4 inch wide. Every time they tried to do it different, it would come out different. Anyway, I'm going to stick some numbers in these holes here. I like to put the numbers right on the parts, but the edge of the plywood is kind of narrow to make a number that's readable on a 8.5 by 11 piece of paper. So I'm just going to put this little leader. I'm not even going to put arrowheads on it. I want to make sure it looks different than these. And I wrote 48 inches here. I don't know what the plywood we buy will actually be. It could be anything. So those pieces will be squared, 48 by 48. 48. So the stairs will be 45 inches wide, 44 inches wide. Because those, the treads and risers goes out to this lumber on the side here. And then there's the plywood, the phenolic boards inside of that. Now, once you take all that away, the concrete that fits between them will be narrower than this 48. But the 48 is the best use of the plywood. Just cut strips, you know, left to right and nothing left over. I haven't figured out what to make out of this chunk here yet. But we'll figure out something. Because we know exactly what size it is. It'll be on the drawing here. Okay. Anything else today? Don't think so. I had drawings. In case you don't watch the other video, which is really likely. You wonder why this thing is delaminated. I did too. I couldn't figure out how we had wrecked these forms. When 36 uses on the last time we used this phenolic board on the other forms. And this is 9 pours, and some of them look like crap. What it is they left out 60% of the through bolts that hold it together. Even though when they told me they were short, we bought a bunch more threaded rod and had them cut them. And bought the nuts and washers and all that stuff that goes with it. But somehow they decided they didn't really need them. And nobody asked. They just didn't need them. They didn't put them in. So what happened, if you don't put them in, you need to put a piece of duct tape, you know, the canvas type duct tape, not the real duct tape, but duct tape, D-U-C-K. I guess you spell it the same, but it's a different thing. Let's see here. Yeah, you can see it better now. And they were telling me that they couldn't flip them over. I'd always figured I would run these about 20 times. I'd take the screws out, and since everything is exact, they could flip the sheet over, just flip it in for in, and the holes for the bolts would line up, and the screw holes, we don't want them to line up if you put a new side on. If they do, they do, but if they don't, that's all right. But I was figuring I could get double use out of this. But what they did was they didn't put the tape over it. They may have put the WD-40 on it to keep it from sticking, or they might have used oil when we were quarantine locked and couldn't get across into the out of town. Basically, couldn't get away from the street we were on. That's how we got such a big crew for a while. So when they didn't put anything with it, the concrete from the left out bolts was filled these holes up. So they go around and they smack it with a piece of rebar one way, and then after they got them all loose a little bit, which delaminated the back side. It doesn't show here, but if you turn it over, you can see that they've delaminated the side that's not in the concrete. Then they turn it back over and knock it clear out on this side, and that delaminates this side. So pretty much, we're going to have to buy about 20 sheets of phenolic board to fix all this. You can see the tank up here. Well, you can't see it because it's off the screen. And now it's really off. You can see the finish on this tank. That's the way it comes out of the forms. You know, that's a pretty finish for a Japanese pillbox. You know, they didn't pour them that neat. They're still around. That was what, 1942 and 43? Long time ago. Going on 60 years. You can see they had holes here. That top row had most of the holes. Didn't have the one here. Didn't have the one there. Didn't have the two here. And didn't have any of these rows. Not a bit. There's no bolt holes here holding them. If they left the bolt holes out of the top row, when they go and bring another set of bolt holes up, there's nowhere to put the threaded rod through the bolt holes. It's solid concrete behind the phenolic board. So, that being the case, when they poured the dirty kitchen, they were still leaving them out. You know, it's 3, 6, 9, 10, 11, 12. The 12th pour on these forms, they still weren't putting all the bolts in. I don't think they're going to put them in all anytime. See, here's a row over here that's got one. Don't know why I had one out in the middle of nowhere. Here's another one got one. Must have made sense at the time. But those set the thickness of your wall. That orange pipe spacer, they're knocked out here now, but that orange pipe spacer tells the thickness of the wall. So if you don't have the thing it could be in, or the concrete could buckle it out and change the wall thickness. This is such a simple way to build a building, this slip forms. It's regular poured concrete is 15% cheaper than hollow blocks. If you pour the same thickness of wall, being many times as strong, you could pour a much thinner wall, and it would still be far superior in strength. And the 15% goes to 35% real quick. But we left it thick because it's only got an R value of 2. So 7 inches of wall times 2 is R14. And you're only looking to do a 1-day heat cycle. It's a thermal mass house. And 7 inches of walls made sense to us, so we only saved 15%. Plus many, many hours of labor. Anyway, the forms are delaminated by not putting the bolts in the holes, which also left out the spacers, not a good thing. And this is what poured concrete looks like, done by pretty much us amateurs. Oh, we ran past the video time here. It's still recording, but it's going to quit in just a second. So that's all for this video, and y'all have a fine day. Say hi to God for us. This little short prayer. You don't have to push like and like, subscribe. Don't have to comment. But if you push don't like, it'd be only fair for you to make a comment why you didn't like it. And these are content type videos. They're not all polished up and scripted and edited and everything. They're just what you see is what you get. and bear that in mind when you give me negative comments. Of course, I don't get comments of any kind, so it doesn't make any difference. And there may be 0 views to this. A year from now, I might get a view on it, but it's so that other people will know what we learned when we built this house. Because we started out not knowing anything. I build machinery, race cars, motorcycles, some from scratch. Well, mostly all from scratch. But a lot of times I'll use a motor out of a car or out of another motorcycle. The airplane, I did the motor too. But it's a 5-rotor Wankel, tuned down to 630 horsepower. But it's just a matter of the adjustment on the turbine. It has a turbocharger on it. Just screw in the wastegate and it goes 1,800 horsepower just right now. And it burns the same amount of fuel as 1,800 horsepower of anything. It's fixed up so that it can reject the heat and run at those speeds, but there's no need, really. It's a light airplane, doesn't weigh much. 2,500 pounds all up, plus fuel. That's dry weight. 2,630 some pounds. That's not 2,500. Okay, end of the video.